So today we are going to start another problem that is again a linear programming problem, but it is a special case of linear programming problem that is known as the transportation problem. Okay, so today we are going to start with the transportation problem and let us see what we have to deal with in the transportation problem. Okay. Okay. So let's take an example to understand what this problem deals with. Okay, transportation problem. Suppose I have some manufacturing points or the supply points of any product. Suppose we take an example of an LCD. Suppose we take an example of Samsung LCD. Okay. Suppose the Samsung company manufactures this LCD, and suppose in a particular area it is available. It is manufactured at 3 points. Okay, it is manufactured at 3 points. Okay, जहाँ पे ये manufacture होता है या जहाँ पे इसकी supply होगी, those are known as the supply points. Suppose in a particular area we have 3 supply points. I will show you by the example here what we have to do in this transportation problem. Suppose we have 3 supply points. Suppose this is the supply point 1. Let me take this as the supply point 1, this as the supply point 2, and suppose this is the supply point 3 here. Okay, there are the 3 supply points or the 3 manufacturing points where this Samsung LCD is manufactured. Okay, these are known as the supply points. Therefore, I can write that this is the supply point 1, this is the supply point 2, and this is the supply point 3. Okay, we can have many supply points. Okay, for understanding, I'm taking the example of 3 points. And in that area, there we have, okay, किसी region में, किसी particular region में, there we have 3 demand points. Okay, I will take an example of 3 demand points. Although we can have 4 demand points, 5 demand points, 6 demand points, okay, whatever, 2, 3. But let me take an example where we have 3 demand points. So in a particular region, I have considered 3 manufacturing points, and these are known as the supply points, from which we can supply any product. Okay. For example, in this case, I have considered the example of the Samsung LCD. So these 3 are the supply points, and जहां से supply points को ये देना है, these are known as the destination points. These points will be known as the destination points or demand points. Okay, so from here we have what? We have supply points, and sometimes these are known as the source points. Okay, supply points or the source points. These are known as the demand or destination points. Particularly, these are known as destination points or simply destinations. जहां पे हमें goods को supply करना है from the supply point to the destination points here. Okay, let us suppose that, okay, obviously there will be some transportation cost involved in supplying the products from the supply points to the required destinations. Okay, and there will be some cost associated with it. And for the time being, I can also assume that for a particular interval of time, okay, we can take roughly a particular interval of time, maybe a day, 2 days, a week, a month. Okay, let me take some fixed interval of time, and I say that during this fixed interval of time, how many units of this are manufactured. For example, I say that 50 LCDs are manufactured in the supply point 1, okay, or in the source point 1, 50 units of this LCD product are manufactured. Similarly, मैं कहता हूं कि जो ये सप्लाई पॉइंट 2 है, ओके, सोर्स 2, यहाँ पे जो मैन्युफैक्चर होता है इसी इंटरवल ऑफ टाइम में, ओके, आई कैन फिक्स सम इंटरवल ऑफ टाइम, सपोज इट इज अ 1 वीक इंटरवल ऑफ टाइम, उसी दौरान कितने मैन्युफैक्चर होते हैं, 35, ओके, जस्ट एज रफली एन एग्जांपल. सिमिलरली आई से दैट इस वाले इंस्टेंट पे, इसी पर्टिकुलर इंस्टेंट ऑफ टाइम में कितना होता है, 40 units of this Samsung LCD are manufactured here. Okay, so I have given that in a particular interval of time, what is the capacity of the different supply points to manufacture the items. Okay, so this is the And this is what, this is the supply. Okay, in a particular in a particular interval of time, this source one can supply 50 units. In that same interval of time, this source S2 can supply 35 units, and this S3 can supply 40 units. Now I am going to take an example of demand. Okay, suppose this is a destination point or a demand point or some shop. Okay, destination क्या है, ये कोई shop भी हो सकता है. ठीक है, किसी मैन्युफैक्चरिंग यूनिट से फिर इसको ट्रांसपोर्ट करना है टू द शॉप. सपोज दिस इज द डेस्टिनेशन पॉइंट हियर. ओके, देयरफॉर इट कैन बी अ शॉप सिंपली. इसकी कुछ डिमांड होगी इस इंटरवल में. ठीक है, सपोज मैंने एक वीक का इंटरवल लिया है. आई एम टेकिंग एन एग्जांपल ऑफ एन इंटरवल ऑफ 1 वीक. इसी 1 वीक में इसकी डिमांड क्या होगी. सपोज इट्स डिमांड इज 20 यूनिट्स. ओके, इट नीड्स 20 यूनिट्स इन दिस 1 वीक. सपोज इस destination point 2 key. Okay, for this destination 2 or shop 2, the demand in the same interval of time is 60 units, and also the demand for this is 45 units. Okay, I have roughly taken an example, that is I have 3 supply points or 3 manufacturing points or 3 source points, and here we have what, 3 destinations or 3 shops jahan pe ye deliver karne hai goods. Okay, so we can see that I have taken an example of three supply points and 3 destinations. It's not necessary that jitne supply points honge utne destinations bhi honge. Okay, it is not necessary. We can have 3 supply points and 4 destinations, 5 destinations. Okay, we can have 5 supply points, 2 destinations, 3 destinations. Okay, but I have taken an roughly an example where supply points and destinations are same. Obviously, there will be some cost involved in transporting the goods from the supply points to the destinations. Let me show it here. Let me consider an example where agar S1 se ja raha hai, if the goods are being taken from source 1 to the destination 1, I say that the per unit cost in transporting 1 unit of this Samsung LCD from the supply 1 to the destination 1 is equal to, suppose, rupees 8. Okay, it is the cost involved in what, in transporting, it is the cost involved in transporting 8 units. Sorry, it is the cost involved in transporting 1 unit of this product from supply 1 to destination 1. Similarly, if he is transporting the same product from supply 1 to destination 2, okay, he is transporting the same product from supply 1 to destination 2, it is not necessary that the same cost will be involved in transporting this product from supply 1 to destination 2. Suppose the cost involved in this process is rupees 7 per unit. Okay, in transporting 1 unit of this LCD from supply 1 to the destination 2. Similarly, we can see that the supply 1 can also give the product to the destination 3. And let me suppose that the cost involved here is rupees per unit. The cost involved is rupees 5. Okay, these are the cost involved. Similarly, we can take the example of this supply 2. It can supply to destination 1, it can supply to destination 2, it can also supply to the destination 3, and there will be different costs or the same costs that will be involved. Okay, let me take an example. 3 rupees per unit. Let me take an example here. 4 rupees per unit, and let me take an example here that 7 rupees per unit will be incurred in transporting it from S2 to D3. Similarly, now finally, we can also see that there will be some costs involved in transporting from S3 to D1, from S3 to D2, and from S3 to D3. And let me give a rough example of the costs here. Suppose this cost involved is rupees 10. Suppose this cost involved is rupees 5. And suppose this cost involved is rupees 6 per unit. Okay, all these costs are in terms of the per unit. Okay, so we have to see what is the best possible way to supply the products from the supply points to the destination point so that our overall cost is minimized. Okay, this is our main aim here. Okay, this is our main aim here. So this is the rough idea what is going on. Okay, we have some supply points. So I have 3 supply points and I have 3 demand points. Okay, and we can see that there will be some cost incurred in transporting the goods from one supply point to the one destination. Okay, and these costs are on the basis of per unit. Okay, these costs are on the basis of per unit. Let me give an example. Simply, I can roughly take an example here. Suppose the suppose the supply of source one, okay, it can supply how many units? It can supply 50 units. Okay, I'm giving an example here. It can supply 50 units. Okay, it can give to destination 1, 2 and 3 respectively. Okay, suppose I am taking an example that S1 is giving 20 units to D1. Okay, S1 is giving 20 units to D1 here. Okay, S1 is giving 20 units to D1 here. Therefore, S1 is giving to D1 how many units? It is giving 20 units. Okay, इसकी demand कितनी है? इसकी demand 20 units है. Suppose whole of his demand is met by S1. ठीक है? Then I can say that what are the units that has been transferred from X1 to D1? Okay, let me say that Xij actually represents what? Xij represents the quantity transported from point I, okay, supply point I to destination J. Okay, it is transporting I units. Okay, it is transporting how many units? X11 units. Okay, जब मैं बात करता हूँ X11 की, that means how many units are being transported from supply point 1 to the destination 1, and I have taken them to be 20. Isn't it? I have taken them to be 20. अब इसके पास कितना बचा? कोई मुझे बता सकता है? Supply इसकी थी 50. Okay, it could have supplied 50. It supplied 20 units to the destination 1. Now how much amount is remaining with it? Okay, how many units are remaining with it?
30.
Okay, obviously its capacity is 50. It has given away 20 units. Now he is left with 30 units. So let me say that out of these 30 units, he is giving 20 units to this. Okay, he is giving 20 units to this destination 2. Therefore, I can see that X12 here. Okay, X12 means 1 से जा रहा है और 2 की तरफ आ रहा है. That is, it is going from the destination 1. Okay, I have represented I as the source and destination as the J. Therefore, he is giving how many units to it? 20. Okay, he's giving 20 units to it, and he is left with now 10 units. Okay, iski supply thi 50, 20 he has given to destination 1, 20 he is given to destination 2, and now he is left with 10. Therefore, rest of the 10 units he will give to the destination 3, that is 10. Okay, similarly, what can we have here? We can have the values of different values of x1, x21. That means source 2 1 को कितना दे रहा है, destination 1 को कितना दे रहा है, source 2 destination 2 को कितना दे रहा है, source 2 destination 3 को कितना दे रहा है. Okay, these are the units which he is giving, the source 2 is giving to the destinations 1, 2 and 3. Okay, so many combinations are possible here. Okay, in some other example, I can take that he is giving 10 to this, 15 to this, 15 to this. Okay, so many combinations are possible. Unlimited combinations are possible here. Okay, source 1 can give 10 units to 1, 15 units to 2, 15 units to 3. Okay, in fact we can write here 20 so that the supply is exhausted. Okay, 15 is 30 and 20, that means it is 50 total. Okay, so this is another combination possible. So we will have so many combinations, and along with these combinations we will have so many costs. Okay, along with these combinations we can have different costs here. Okay, So let me calculate the cost for this. अगर मैं इसका cost calculate करूं, so X11 means 20 units are being transferred from source 1 to destination 1. So what will be the total cost associated with this? Can anyone say? Per unit को transport करने में from 1 to 1 is ₹8. Since I am transporting 20 units from 1 to 1, the total cost will be what? 160. Isn't it? It will be simply cost per unit multiplied by the total number of units which are being transferred from 1 to 1. Similarly, the cost involved in transporting 20 units from source 1 to destination 2, that will be 20 multiplied by what? 7. 7 is the per unit cost in transporting from 1 to 2. Therefore, it will be equal to 140. Similarly, in transporting from destination 1, source 1 to the destination 3, the cost incurred is ₹5, and we are transporting 10 units from 1 to 3. Therefore, total cost that will be incurred will be ₹50. Similarly, there will be some costs that will be incurred in transporting from 2 to 1, 2 to 2, and 2 to 3. And finally, there will be some more costs which will be incurred in transporting from 3 to 1, 3 to 2, 3 to 3. For different combinations of these x1, x2, x3, x4, okay, sorry, x11, x21, x23, x12, x21, we will have so many combinations. But there will be one optimum combination, okay? There will be one optimum combination which will minimize the cost. We want this cost to be minimized. We want the overall transportation cost to be minimized, okay? So this is the goal of the transportation problem, that we have to see किस source से हम किस destination को कितने units दे. How many units should be transferred from which source to which destination, so that our overall cost is minimized, okay? So I think the brief idea regarding the transportation problem is clear to you, that we have to minimize the transportation cost that is incurred while we are supplying the goods from the source points to the destinations, okay? We want to minimize this overall cost here, okay? So I can generalize this problem here. I can write that let xij be the quantity to be transported from source I to the destination J. Okay, in my problem currently, I can have the values from 1 to 3 because I have 3 sources, and J can have the values from 1 to 3 because I have the 3 destinations, okay? It will be a variable. So Xij is the quantity to be transported from source I to destination 1. Let me take an example that X23. What does this mean? This means number of units transported from source 2 to the destination 3. Okay, so this is the significance. What do you mean by Xij? I will have the values 1, 2, and 3. J will also have the values from 1, 2, and 3. Okay, can anyone say how many variables will we have? Okay, these will become the decision variables. जैसे वहां पे होता था x1, x2, x3. Okay, they were the decision variables. Can anyone say in this problem how many decision variables we can have? How many decision variables we can have?
Nine.
Very good. If m are the supply points, if m are the number of supply points, and n are the number of destinations, okay, then total number of decision variables will be कितना होना चाहिए?
M cross N.
Okay, simply m into n. Okay, in our problem, the number of decision in this what we call as the destinations, sorry, the sources are m, this 3, and the decisions are also destinations are also 3. Okay, sources 3, destinations 3. Therefore, total number of xij that we will use here is will be 9. Okay, and you can see that यहाँ से भी आपको खुद से दिखाना, ये arrows कितने आए total? 9. There are 9 possible ways. Okay, there are 9 possible ways to transport. Okay, you can see that I have drawn 9 arrows. Okay, 3 from each color. Okay, so there are 9 decision variables that will be used here. Okay, there are 9 decision variables that will be used here. Now let me define one more term, that is Cij. Okay, it is the cost per unit in transporting from source I to destination J. It is the cost per unit in transporting from source I to destination J. Okay, so suppose let me take an example of C32. What does this mean? It means cost per unit in transporting from source 3, third source point, to the destination second. To destination 2. Okay, in my example, can anyone say what will be C32? जो मैंने rough example दी थी यहाँ पे, what will be C?
5.
Okay, very good. You can see that what is the cost per unit in transporting from the source 3 to the destination 2. I have represented that by rupees 5. Okay, per unit, it is the cost per unit. Okay, therefore this will be, अगर इसका हम unit लिखते हैं, the unit will be rupees per unit. Okay, and when we multiply it with number of units, then unit and unit will cancel. We will get the unit as cost का unit जो आएगा, that will be rupees. Okay, so the Cij is the cost per unit. Okay, so finally what our decision problem becomes here, the problem becomes here minimization problem, because we have to minimize the cost. Okay, we have to minimize the cost, therefore the problem is of minimization. Therefore the problem becomes that minimize z equal to summation of I, summation of j. What we have to minimize is the total cost. Okay, what we have to minimize is the total cost. Therefore we have to minimize this quantity. We have to minimize Cij multiplied by Xij. ठीक है, total cost कैसे मिलेगा? Cost per unit in transporting from one source to another destination, multiply by with how many units we are transporting from that source to that destination. Okay, that will give us the total cost. Okay, obviously that will give us the total cost. जो मैंने यहाँ पे भी example ली थी, I have taken an example that I am transporting 20 units from 1 to 1 and the per unit cost is rupees 8. Therefore, the total cost involved in transporting from 1 to 1 will be given by 20 into 8. That was 160. Okay. So this is the problem which we have to solve. Okay. This again becomes the problem, linear programming problem. Okay. So in this transportation problem, we have to minimize the transportation cost, and the transportation cost is the product of the cost per unit in transporting from a particular source to particular destination multiplied by with how many units we are transporting from that source to that particular destination. Okay, fine. Is it correct? This is the what? This is the objective function. Okay, this is the objective function, but it has to be subjected to certain constraints. It has to be subjected to certain constraints. कोई मुझे यहाँ पे बता सकता है कि constraints क्या क्या होंगे यहाँ पे? What will be the constraints? रफली अगर बताएगा constraints किस बेसिस पे होंगे?
Transportation.
Number of words produced.
Okay. There will be two constraints. One constraint will be with reference to the supply. Okay, इसकी capacity कितनी है supply करने की? And another constraint will be with reference to the demand. Okay, there will be two restrictions. Okay, there will be two restrictions. One is the restriction with respect to supply, and another is the restriction with respect to demand. Okay. One more thing that we assume in the transportation problem is that transportation हो सकती है from source to destination only, not from destination to destination. कोई कहेगा सर पहले हम source 1 से destination 1 तक लेंगे फिर destination 1 से destination 2 तक लेंगे. So we don't deal with such kind of problems in this transportation problem. Therefore, every transportation problem उसमें हमें क्या होगा? The transportation of the goods will take from source to destination, not from destination to destination. Okay, this is one assumption that we use here. Okay, so I will write the first constraint. The first constraint is the first constraint is with respect to the supply. Okay, this constraint is with respect to supply. This is the constraint with respect to supply. इसका मतलब क्या है यहाँ पे ट्रांसपोर्टेशन प्रॉब्लम में? इसका मतलब क्या है? See here, let me take example of source 1. If I'm taking an example of source 1, तब ये constraint क्या हो जाएगा? This constraint, if I'm taking an example of source 1, then I will be equal to 1. I will be equal to 1. ठीक है? अगर मैं source 1 की बात कर रहा हूं, then I will be equal to 1. And J can take the values of 1, 2, and 3. ठीक है? I am talking about a particular source. I am talking about source 1. For source 1, I is equal to 1. Source 1 से कहां जा सकता है? Destination 1, destination 2, destination 3. Therefore, J can take the values of 1, 2, and 3. Therefore, if I expand this constraint, what does that mean? It means that x11, that is number of units that are being transferred from 1 to 1 plus number of units that are being transported from 1 to 2 plus number of units that are being transported from 1 to 3, they should be equal to what? इसके बराबर होना चाहिए AI or A1. I will write here 1 because I am talking about the source 1. Therefore, I have put I equal to 1. And A1 represents what? It represents the supply of source 1. Supply of source 1. है ना? यही होना चाहिए. So A1 मेरी example में क्या है? जो मैंने example ली थी. What is the A1 here in my example? A1 means the supply of 1. What is the supply of the first source? That is equal to 50. That is equal to 50, isn't it? In my example, this is equal to 50. Therefore, source 1 से कितने यूनिट्स जाए 1 को, 2 को और 3 को? जो मैंने एग्जांपल ली थी यहाँ पे, रफली एक एग्जांपल ली थी, मैंने कहा था 1 से 1 तक 20 जा सकते हैं, 1 से 2 तक अगर 15 गए, तब 1 से 3 तक 15 जाने चाहिए, so that their sum is equal to what? 50. This is the constraint with respect to the source 1. कोई मुझे बता सकता है कितने constraints आएंगे, इसके further कितने constraints आएंगे? ये simple एक ही constraint नहीं है, it is representing how many constraints in total? In my example, in my current example, how many constraints it is representing?
3.
Okay, obviously it will be 3. I have expanded it for the source 1. You can expand it for the source 2. And if I am expanding it for the source 2, then this constraint will become x21 plus x22 plus x23. कितने units जा सकते हैं from source 2 to 1, 2 to 2, 2 to 3? उनका summation कितना होना चाहिए? That should be equal to the supply of the source second. And A2 in my example was how much? A2 in my example was 35. And this is the constraint for the source 3. Source 3 के लिए अगर हम लिखेंगे, it will be इतने number of units from 3 to 1, इतने number of units from 3 to 2, this much number of units from 3 to 3. It should be equal to the supply of the source 3. Okay, so the general way of writing this constraint is what? This summation of xij. Okay, j can take value from what? Here it can take value from 1 to 3. अगर 4 destinations होते, j could have taken the value from 1 to 4. Okay, therefore I have simply written here j. Okay, and 1, this constraint will be different for different sources. तो कितने constraints आ गई अभी तक? We have in fact 3 constraints. Okay, we have 3 constraints. It is not a single constraint, it is a constraint for each source. And since we have 3 sources, therefore in total we have these 3 constraints here. Okay, so this is the significance of this constraint. Okay, again, it is not a single constraint, it is the constraint for 3 different sources. Now let's write one more constraint here. The another constraint will be with respect to, it will be with respect to what? The demand. It will be with respect to the demand. And यहाँ पे vary क्या करेगा? I will vary. Okay, I will vary. And this is bi. Sorry, bj होगा यहाँ पे, ठीक है? This is bj. So this constraint is with respect to the demand. This is the demand constraint. So if I'm evaluating it for the destination 1, if I'm evaluating it for destination 1, then j becomes 1 and I can take values from 1, 2 and 3. ठीक है? Destination 1 जो है वहां पे कहाँ से आ सकते हैं? Source 1 से आ सकता है, Source 2 से आ सकता है, Source 3 से आ सकता है. तो कितना आना चाहिए? Source 1 से destination 1 तक, Source 2 से destination 1 तक, Source 3 से destination 1 तक जो भी आना चाहिए वो किसके बराबर आना चाहिए? That should be equal to the demand of 1. That should be equal to demand of destination 1. So I am writing the constraint of the demand. Again, this demand constraint is not a single constraint. It will be for different demand points. Okay, I have written the first constraint. Okay, I have written this constraint. It is for the demand point 1. Similarly, if I am going to write the second constraint, okay, can anyone see in my example what was B1? It was the demand of the first one in my current example, which I had taken roughly. The D1, sorry, B1 is 20, okay, because the demand of the destination 1 is 20, okay. तो जितने भी number of units यहाँ की तरफ आने चाहिए from source 1, from source 2, from source 3, उनका addition जो होना चाहिए, that should be equal to the demand of this end, which is 20 here. Okay, so B1 is here what? Actually, in my example, it is 20. Okay, in my example, it is 20. Similarly, if I'm going to write the constraints for the other demand points or destination points, then I can say that now for the another demand point, J will be 2. And it can receive units from first, it can receive units from second source, and it can receive units from the third source. And that should be equal to the demand of that shop or the demand of that particular destination. Okay. Similarly, if I'm going to write for the third destination, it can receive from 1, it can receive units from 2, it can receive units from 3, and that should be equal to the demand of it. Okay, B3. And one more thing here is that all these decision variables should be greater or equal to 0. It should be greater or equal to 0. या तो हम कुछ यूनिट्स ट्रांसपोर्ट करेंगे फ्रॉम सोर्स आई टू डेस्टिनेशन जे, या कुछ ट्रांसपोर्ट ही नहीं करेंगे. ओके, इट्स नॉट नेसेसरी दैट कि हर किसी सोर्स से हर किसी डेस्टिनेशन को जाना चाहिए. It is not necessary. Xij can also be equal to 0. That is, it is possible that, suppose I am taking an example of x21 is equal to 0. If I am taking an example that x21 is equal to 0, that means हमने सोर्स सेकंड से डेस्टिनेशन 1 को कोई भी ट्रांसपोर्ट नहीं किया. देखिए, डेस्टिनेशन 1 को डिमांड है, सपोज उसकी डिमांड 20 यूनिट्स है. इट डजंट मैटर फॉर हिम दैट इसकी डिमांड कौन फुलफिल करे, 1, 2 or 3, or the combination of 1, 2, or combination of 1, 3, or combination of 2, 3, या उसकी डिमांड कोई एक ही सोर्स कंप्लीटली फिल कर सकता है. ओके, therefore it's not necessary that something should go from some destination, from some source to some destination. There can be certain instances that nothing is going from particular source to a particular destination. Then in that case, xij will be 0 for that particular case. Okay, therefore I am writing that xij should be either greater or equal to 0. Okay, but it can't be negative. इसका कोई मतलब ही नहीं है that we are sending -4 units from particular source to particular destination. Okay, this is one thing. Okay, so again you can see that this transportation problem is a linear programming problem itself, isn't it? Okay, अगर मैं फिर से इसको लिखूं यहाँ पे, the problem is minimize z equal to summation of I summation of j. What we have to minimize the total cost, and that total cost is this. Okay, Cij multiplied by Xij, and the constraints are subject to summation of Xij j should be equal to what? Ai. Okay, this is the supply constraint. ये supply constraint है. Summation of I Xij should be equal to Bi. This is the demand constraint. This is the demand constraint, and Xij should be greater or equal to 0. Okay, this is again a linear programming problem. कहीं पे आपने किसी decision variable पे square देखा, cube देखा? No, we haven't seen. Again, therefore, this transportation problem is again a linear programming problem. Transportation problem is simply a linear programming problem. We can solve it by algebraic method, we can solve it by simplex method, but you can see that there will be very complex solutions. Okay, अगर हम simplex method से इसको solve करने की कोशिश करेंगे, it will be very complex because how many variables we have here? We have 9 variables. Okay, जो मैंने example ली थी, for example, in my example I had taken 9 variables. Okay, 9 variables आ गए थे, x11, x12, x13, similarly up to x33. And how many constraints we have here in my problem, in my example? We had 6 constraints. ठीक है, ये 3 constraint है, ये 3 constraint है. Total we have 6 constraints. So just imagine how much complex will the simplex table get if we try to solve it by the linear programming methods which we have read up to this point. Okay, but we have certain better and faster methods to solve the transportation problems. That's why, what is the goal of this unit? Okay, that is the goal of this topic, that what are the methods so that we can minimize the cost, find the optimal solution, and minimize the transportation cost. Okay, obviously it will be very difficult by using the previous linear programming techniques which we have studied. Therefore, for the transportation problem, we have certain different techniques that we need to learn in this unit. Okay, so I think the overall problem has been defined. What is the problem here, and how to solve that problem? We will going to discuss it now. Okay, so before moving forward, if I write that AI is equal to, यहाँ पे bj होना चाहिए, is equal to bj. Okay, in fact summation, sorry, because AI is for the particular demand supply point and bj is for the particular demand point. If I sum all of these, okay, what does summation of AI mean? Let me tell you that. If I move back to my example, summation of AI will be the summation of the supply of all these sources. Summation of AI क्या होगा? Summation of AI means A1 plus A2 plus A3. A1 is 50, this is how much? This is 35 and this is 40. So इनका जो summation आएगा, how much that is? It is 125, isn't it? 50 plus 40, 90 and it is 125. तो summation of AI जो मैंने वहां पे लिखा, उसकी यही significance है. What is the total supply of all these combined sources? Okay, what is the total supply of all these combined sources? Similarly, right hand side से मैंने लिखा summation of bj. Summation of bj represent करेगा what is the total demand, cumulative demand of all these three destinations. You can see that if I am going to add them, 60 plus 20 is 80, 80 plus 45 is again 125. And if this situation occurs, okay, if this situation occurs where summation of the sources, okay, summation of the total supply is equal to the summation of total demand. Okay, what is this referring to? This is summation of total supply. And this is the summation of total demand. Okay, if this condition arises, then we can say that the transportation problem is a balanced transportation problem. And for the time being, we will deal with only such problems. It is a balanced transportation problem. So a balanced transportation problem is that one in which the total summation of the supply, okay, total supply is equal to total demand. Okay, in short, we can say that balanced transportation is that problem in which total supply is equal to total demand. Okay, total supply is equal to total demand. Okay, so currently for the time being, we will deal with only balanced transportation problem. Later on, we can see that couple of questions on the unbalanced transportation problem, जिनमें जो total supply or total demand होती है, they are not equal. Okay, so for time being, we can start with the balanced transportation problems. So this was till this point, this was only the problem formulation. Okay, transportation problem में हमें करना क्या होता है? What is the goal of the transportation problem? The goal is to minimize the total transportation cost, and I have represented the total transportation cost in terms of summation of Cij multiplied by Xij, and I have seen what are the constraints. Okay, what is the supply constraint and what is the demand constraints, and I also told you that why we can't use this simplex method for, because there are so many variables and so many constraints. This will become a huge matrix. Okay, therefore we have some certain techniques to solve the transportation problem. And what are those techniques that we are going to learn? जो transportation problem का solution होता है, that is divided into two steps. The solution of the transportation problem is divided into two steps. The first step is First step is find an initial basic feasible solution. Okay, the first step is find an initial basic feasible solution. आपको पता है कि initial basic feasible solution क्या होता है? कोई भी solution जो एक possible solution हो, okay, which is a feasible solution, which is a possible solution, ठीक है? जो भी हमने examples ली थी पिछले केस में, वहां पे बहुत सारे solutions मिलते थे. There were so many basic feasible solutions, but one was the optimal solution, okay? So first of all, what we have to do in the transportation problem is that we have to find an initial basic feasible solution. The second step is to check whether the initial basic feasible solution is optimal or not. ठीक है, तो पहला स्टेप क्या होगा? फर्स्ट स्टेप विल बी फाइंड एन इनिशियल बेसिक फिजिबल सॉल्यूशन, एंड वंस यू हैव फाउंड द इनिशियल बेसिक फिजिबल सॉल्यूशन, उसके बाद क्या करना है? उसी सॉल्यूशन को चेक करना है whether that initial basic feasible solution is optimal or not. Okay, and if it is not optimal, then find the optimal solution. अगर ये optimal है, if optimal, then we don't need to go further. Okay, if that solution is not optimal, then what we have to do? Find the optimal solution. This will be the sequence of the steps that will be followed in the transmutation problem. First of all, we have to see what is the initial basic feasible solution, and later on we can check that whether that initial basic feasible solution is the optimal or not. Agar ye optimal nahi aaya, then find the optimal solution. And for finding the initial basic feasible solution, we have to learn three methods. The first method in finding the initial basic feasible solution is known as northwest corner method. The first method is known as northwest corner method. The second method is known as least cost method. And the third method is known as Vogel approximation method. आज हम पहले दो डिस्कस करेंगे, ठीक है? WAM takes a lot of time, but we will discuss northwest corner method and least cost method, okay, to find the initial basic feasible solutions. And how we check whether these initial basic feasible solutions are optimal or not? They are checked by two methods. One is known as Narendra Modi method. Okay, it is known as Modi method, and second is known as stepping stone method. Stepping stone method. Okay, so the first three methods, that is northwest corner, least cost method, and Vogel approximation method, these are used to find the initial basic feasible solution. And to check whether they are optimal or not, we have to use Modi method or stepping stone method. Okay, so today we will deal with some initial basic feasible solution techniques. Okay, the first technique is the northwest corner technique. Northwest corner method, sometimes it is written in short form as NCW, okay, NWC in fact. Okay, I will show you how the problem will be given in the question. The problem is in the form of a table. Okay, the problem is in the form of a table. This is how the table looks like. Okay, I will actually write the question now, and from the question we can see that, देखिए क्या दिया होगा यहाँ पे, in this question there are 4 sources. Okay, this is source 1, this is source 2, this is source 3, and this is source 4. यहाँ पे होंगे destinations. Okay, this is the destination 1, destination 2, destination 3. तो मैंने आपसे पहले ही कहा था that it is not necessary that the number of source points are equal to the number of destination points. Okay, in the first example I had taken the number of source points 3 and the number of destinations equal to 3, but I told you that there will be different number of sources and different number of destinations. So in my current case, the number of sources are equal to how much? 4. The number of destinations are n, they are equal to 3. Can you tell me how many decision variables will we have? How many decision variables in this case shall we have?
12.
So xij, that is the number of decision variables, that will be equal to m into m into n, है ना? x11, x12, ठीक है? कितने number of cells बन गए यहाँ पे? 12. Okay, these are the 12 decision variables we shall have in this case. Okay. Also, what is given in the question here is the cost per unit. The cost per unit will be given in the questions. This is 2, this is 7, and this is 4. This is 3, this is 3, this is 1. This is 5, this is 4, this is 7. This is 1, this is 6, and this is 2. Okay. These are the costs which are cost per unit. Okay, these are the cost per unit which we incur in transporting from a particular source to particular destination. Suppose मैं example currently लेता हूँ इस चीज की यहाँ पे. Can anyone say what does this mean? What does this mean? Anyone? इसको मैं represent कैसे करूँ? What is this?
Source 2 से distance to ये destination 2 पे जा रहा है.
Okay.
Cost का 3.
और source 2 से destination 2 पर ले जाने के लिए, एक यूनिट ले जाने के लिए मुझे कितना cost लगेगा? That means this 3 here is actually what? It is actually C22. Cost per unit in taking the one product. Okay, cost in taking the 1 unit of the product from source 2 to destination 2. अगर मैं ये लिखना चाहता हूँ, what is this thing? This is actually, suppose I am taking example of this. Okay, this 2 here. It is actually C43. That is source 4 से destination 3 तक लेने के लिए एक यूनिट को कितना कॉस्ट लगता है? We are taking ₹2. ठीक है, ₹2 लगते हैं, ₹2 लगते हैं in taking the 1 unit of the product from S4 to D3. Okay, this is the significance of all these terms which are given in the table. Okay, so these only represent what? These represent Cij. Okay, in short, they represent Cij, that is the cost per unit in taking the product from I source to the destination J. This is Cij. What should be written? और क्या पता होना चाहिए हमें? बताइए, क्या क्या पता होना चाहिए इसके अलावा? Yes, students, tell me, इसके अलावा क्या क्या चीज हमें पता होनी चाहिए? Apart from these, we should know what is the demand of each destination. Okay, what is the demand of each destination, and what is the supply or availability of each source? Okay, these are the constraints which we know, we must know. यहाँ पे मैं लिखता हूँ availability. This is availability, and this is demand. Demand हम यहाँ से दिखाते हैं, ठीक है? So I will write in this question what is the availability. It is 5, This is how much? This is 8. This is 7. This is 14. ठीक है, इनका सम करो और मुझे बताओ कितना आता है इनकी अवेलेबिलिटी का सम. What is the sum here? It should be 34, isn't it? The sum of availabilities, okay? The sum of availabilities is equal to 34 here. That is sum of availabilities. AI से मैंने लिखा था. That is equal to 34. इसका मतलब क्या है? इस 5 का मतलब क्या है कि source 1 कितना दे सकता है? Okay, how much is the capacity of the source 1 of supplying? Okay, it can supply 5 units. In some particular interval of time, it can supply 5 units. What is the capacity of source 2? It is 8 units. ये कितना दे सकता है? 8 यूनिट दे सकता है. सोर्स 3 कितना दे सकता है? 7 यूनिट दे सकता है. और सोर्स 4 कितना दे सकता है? It can give 14 units. And what is the demand of the first shop or first destination? It is 7 units. What is the demand of the second destination? It is 9 units. And what is the demand of the third destination? That is equal to 18 units. Okay, it is equal to 18 units. You can see that the sum of the availabilities and the sum of the destinations demands 7 plus 9 is, okay, it is 16. 16 plus 18 is 34. They are both same. Summation of bj is also equal to 34. When these are same, the problem is a balanced problem. Okay, this problem is balanced. Okay, so question यही आपको दिया होगा, and you have to find the initial basic feasible solution by northwest corner method. Okay, you have to find the initial basic feasible solution by northwest corner method. Okay, तो क्वेश्चन में क्या दिया होगा? CIJ दिए होंगे हर कोई, किस सोर्स से किस डेस्टिनेशन को लेने में कितना कॉस्ट लगता है पर यूनिट, और किस सोर्स की कितनी कैपेसिटी है, और किस शॉप को, किस डेस्टिनेशन पॉइंट को कितनी डिमांड है. This all will be given in the question. So now what does northwest corner method say? What does northwest corner method say? देखिए, अगर हम बात करते हैं northwest corner की, we know that if these are the directions, this is north, this is south, this is east, and this is west. Okay, the northwest point will be somewhere here. That is something top left. ठीक है, top left corner. Can't we say from this direction that northwest is a top left corner? तो northwest corner क्या method कहता है? ये method क्या कहता है? It says that start allocating those cells first which lie on the top left corner, which lie in the northwest direction. Okay, which lie in the northwest direction. तो इस केस में सबसे पहली सेल मुझे कौन सी allocate करनी चाहिए? Can anyone say? Which lies in the top left. खुद से बताओ मुझे कौन सी सेल लाई करती है in the top left corner. Cell 1 1, cell 1 2, cell 2 3, cell 3 4, which lies in the top left corner?
1 1.
Okay, obviously cell 1 1 lies in the top left corner. ठीक है, अगर मैं यहाँ पे origin लेता हूँ, if this I treat to be the origin, सबसे northwest corner cell कौन सी है? This is the northwest corner cell. So this method says that allocate that cell first which lies in what? Which lies in the northwest or top left corner पे जो cell lie करती है उसी को आप पहले allocation करो. ठीक है? So see how we do the allocation. Allocation means what? इस cell में कितने units जाने चाहिए? Okay, I will tell you what does that mean. See here. Northwest says that first of all do the allocation in this cell. ठीक है? अगर हम इसी सेल की बात करते हैं, this cell corresponds to source 1. This is the cell 1 1. Okay, you can see that this is the cell 1 1. It corresponds to source 1 and it corresponds to destination 1. Source 1, destination 1. तो बेटा मुझे बताइए source 1 की availability कितनी है? कितनी है availability source 1 की? 5 ये दे सकता कितना है? It can give 5 units. What is the demand of the first destination? What is the demand of the first destination? What is the demand of the first destination? It is 7 units, isn't it? Source 1 can give 5 units. Demand 1 requires, destination 1 requires 7 units. So मुझे बताओ source 1 at max कितना दे सकता है? कितना दे सकता है source 1? कितना दे सकता है source 1 at max?
5.
Obviously, ठीक है? Since its capacity is 5, therefore it can give how many units? It can give 5 units to the destination 1. Northwest corner क्या कहता है? सबसे पहले क्या fill करो? The northwest cell, the cell which lies in the northwest or top left corner. So I am going to fill this cell first, but source 1 has the capacity of 5, but destination 1 has the demand of 7. Only whichever among them is the minimum, 5 or 7. The minimum is 5. Therefore, only 5 units can be allocated to this cell because source 1 की capacity खत्म हो जाती है after allocating 5 units. Okay, isn't it? That means x11 is 5. x11 means source 1 से destination 1 तक कितने units जा सकते हैं? That is 5 units जा सकते हैं, है ना? 5 units जा सकते हैं. Now students tell me, can source 1 give anything to destination 2? Can source 1 give anything to destination 2? जल्दी बताइए.
No, sir.
Why it can't give anything to destination 2? Okay, इसके पास availability कितनी थी? इसके पास availability 5 units की थी. उसने ये सारे 5 units किसको दिए? Demand destination 1 को. Therefore, it can't give anything to cell 2. Okay, it can't give anything to this destination 2. Neither it can give anything to the destination 3. It can't give anything to destination 2 and destination 3 because all his supply got exhausted. इसने 5 दिए destination 1 को, इसकी सारी supply exhaust हो गई. He is now left with 0 supply. Therefore, we put a dash in these two rows, in these two cells. We will put a dash. That is, these cells can't be allocated. Okay, these cells can't be allocated. Okay, because these cells can't be allocated by the source 1. Destination 2 will receive nothing from source 1. Destination 3 will receive nothing from source 2. Source 1. Okay, 2 and 3 destinations will receive nothing from source 1. Okay, so tell me students, what is the demand left with destination 1? What is the demand left with destination 1?
2.
Okay, its demand was 7. 5 has been fulfilled by the source 1. Now he is left with what? 2. He is left with 2. Okay, तो जो ये पूरा रो, टॉप का जो पूरा रो है वो फिल हो गया. ठीक है, उसमें एक सेल एलोकेट हो गई, 2 सेल में एलोकेशन नहीं पॉसिबल है. चलिए बेटा, फिर से नॉर्थ वेस्ट कॉर्नर. अब कौन सी सेल है नॉर्थ वेस्ट कॉर्नर?
S21.
Which is the northwest corner cell now? 2 1. ठीक है, पहला रो खत्म हो गया. Forget about the upper row. Now we are left with this table. Okay, we are left with this table. I will show you. Okay, this has gone now. We are left with this table now. Okay, and you can see that the northwest corner cell is this cell here. Okay, therefore the allocation has to be made in this cell now. Okay, चलिए बेटा मुझे बताइए कितनी एलोकेशन पॉसिबल है इस सेल में?
2.
See here, the source has a capacity of 8. The source 2 has a capacity of giving 8 units, but the destination 1 has the capacity of receiving only 2, isn't it? है ना, destination 1 को कितना चाहिए? 7 चाहिए था. 5 किसने दिए इसको? source 1 ने. अब इसकी डिमांड क्या बची? Demand is only what? 2. Therefore, he will receive, although the S2 has capacity of giving 8 units, but he will receive only 2 units from S2 because its demand is getting exhausted. Okay, its demand is getting exhausted. Now we will write here जो 2 इसकी डिमांड थी वो भी खत्म हो गई, अब इसकी डिमांड क्या है 0. Okay, his whole demand is exhausted. Now students tell me, can this cell जो मैंने टिक मार्क किया है, can this receive something from S2?
Yes, sir.
Okay, yes, it can receive from S2. Can this cell receive anything from, can this cell, ठीक है,
No.
this can't be allocated, okay, because demand 1, destination 1 की डिमांड खत्म हो चुकी है. Therefore destination 1 won't receive anything from S3, nor it will receive anything from S4 because its demand is already fulfilled. Okay, therefore we can mark this by the dash. Okay, we can mark this by dash. That is, अब इनमें allocation possible नहीं है because destination 1 की जो demand थी 7 units की, that is completely fulfilled. Okay, partially fulfilled by S1 and partially fulfilled by S2. Okay, so इन सेल्स का मतलब क्या है? ओके, जो मैंने यहाँ पे डैश किया, अगर मैं इस सेल की बात करता हूँ, दिस सेल मीन्स दैट x12 इज 0, x13 इज 0 बिकॉज सोर्स 1 से डेस्टिनेशन 2 कुछ नहीं जाएगा, सोर्स 1 से डेस्टिनेशन 3 कुछ नहीं जाएगा. सिमिलरली सोर्स 3 से डेस्टिनेशन 1 कुछ नहीं जाएगा, दैट मीन्स x31 इज 0. सोर्स 4 से डेस्टिनेशन 1 कुछ नहीं जाएगा, दैट इज x41 इज ऑल्सो 0. दिस इज द सिग्निफिकेंस ऑफ दीज. ओके, and what is x11? x11 means source 1 से destination 1 कितना जाएगा, that is 5 units. Similarly x21 means source 2 से destination 1 कितना जाएगा, that are 2 units. Okay, अब बेटा मुझे बताओ source 2 पे सप्लाई कितनी बच गई, source 2 पे सप्लाई कितनी बच गई? अब
6.
very good, it is 6. Okay, the supply of source S2 was 8, 2 units it has given away to the destination 1. Now the supply here is 6. ठीक है, which is the northmost corner cell now. अब इतना ही टेबल बचा ये, this table is now remaining. Which cell is the northmost corner cell?
S22.
S22 ना, simply top left corner में कौन सा बचा अब? ठीक है, that is x22. The table which is left behind for us is, this table is left behind. Okay, these cells are left behind and the top left is this. Okay, top left corner में ये cell है. Okay, this will be allocated. चलिए बेटा मुझे बताइए कितनी allocation possible है इस सेल में? How many cells, how many units I can allocate? Very good, it can be 6. Okay, ये सेल क्या है? source 2 demand destination 2, source 2 destination 2. source 2 की कैपेसिटी 6 है, डिमांड 9 है, लेकिन whichever is the minimum that will be fulfilled. Therefore I can allocate 6 units. Okay, I can allocate at max 6 units. Okay, जब मैंने 6 यूनिट्स इसमें एलोकेट किए तो क्या खत्म हो गया? सोर्स सेकंड की सप्लाई खत्म हो गई. इसकी सप्लाई कितनी थी? 8 थी. 2 इसने डेस्टिनेशन 1 को दिए, 6 इसने डेस्टिनेशन 2 को दिए. Therefore its supply is now 0. Okay, its supply is now 0. That means it can't supply anything to this cell, isn't it? It can't give anything to the destination 3 because its supply has exhausted. Okay, what is the demand remaining for the destination 2? इसकी डिमांड 3, 9, डेस्टिनेशन 2 की डिमांड थी 9, 6 has been fulfilled, now it is left with 3. Okay, so this thing is fine. अब मुझे बताइए कौन सी सेल हम करेंगे allocate, which cell is to be allocated now?
S32.
Okay, 3-2 cell has to be allocated. अब इतना टेबल बचा, northwest corner is this cell here. What is the allocation possible?
3.
Okay, this cell belongs to demand 2, source 3 and destination 2. source 3 की कैपेसिटी 7 है, लेकिन डिमांड कितनी है इस सेल में? 3. Okay, minimum will be fulfilled. Therefore this will be 3. इसकी पूरी डिमांड खत्म हो गई. 9 यूनिट्स की डिमांड थी, 6 इसने दिए सोर्स 2 ने, 3 यूनिट्स दिए डेस्टिनेशन 3 ने, सॉरी सोर्स 3 ने. ओके, That means this cell can't be allocated now because demand of 2 was 9, that has been already fulfilled. और यहां से कितना बचा अब? 4, isn't it? This
Yes,
is
sir.
4 because source 3 पे कैपेसिटी थी 7, 3 इसने दिए इसको, अब बचा कितना? 4. अब कौन सी सेल एलोकेट होगी? अब ये दो सेल्स बची ना. अब टॉप लेफ्ट कौन है? टॉप पे कौन सी सेल है? दिस. कितना एलोकेशन पॉसिबल है इसमें?
4.
ठीक है. इसकी डिमांड कितनी है? डेस्टिनेशन 3 की डिमांड है 18, लेकिन सोर्स 3 इसको कितना दे सकता है? 4. That is, this demand has got exhausted, this supply has got exhausted. अब बचा कितना? अब बचा यहाँ पे 14. अब ये फाइनल सेल यही बची, इसकी डिमांड भी 14 है, इसका सप्लाई भी 14 है, and this will be the thing in the balanced transportation problem. Okay, when I allocate 14 here, the demand is also exhausted, the supply is also exhausted. Okay, so this is the initial basic feasible solution by the northwest corner method, and the total cost will be what? If we can see that the total cost, that will be equal to 5 into 2. ठीक है, per unit cost कितना है? 2. हम कितने यूनिट दे रहे हैं? We are giving 5 units, therefore the total cost will be 5 into 2 plus कौन सी सेल allocate हो गई? This cell 2 into 3 plus 6 into 3, ये ऐड कीजिए कितना आता है? 3 into 4 plus 4 into 7 plus 14 into 2. Okay, so कितना है ये टोटल कॉस्ट ट्रांसपोर्टेशन का?
102.
102. 102 rupees. Okay, rupees 102 is the total transportation cost, and you can see that कौन कौन सा decision variable जिसमें कोई positive value आया? x11 is 5, x21 is 2, x22 is 6, x32 is 3, x34 is 4, and x43 is 14. Okay, बाकी cells allocate नहीं हुए, then their xij will be 0. So it's sufficient for today.